Okay. Yes, guys. Thank you so much. And today I will talk about multiple linear regression. And here, when we are talking about multiple linear regression, and make sure that your dependent variable, it could be numerical kind of data. We have it, and rest of input or independent variables, it could be anything. Okay. So for sake of understanding, like I would like to go for creating our own dummy data. Okay. So I would like to go for creating the dummy data for you. Okay. So here I have data is age, and I have approximately 10 age, 10 elements or 10 data points or 10 observation have considered. And the spending score, this is the spending score. And based upon the age and spending score, I would like to go for predict the income of that specific person. Okay. Then here x1 is my age, x2 is my spending score, and this is our income, right? Okay. So that's the reason what I'm taking actually. So this is the only thing I'm considering. I'm holding into the y variable, and rest of two things like age and spending score I'm considering or I'm holding into the x variable. Okay. And I would like to do that, well as a operation, so that well as a ordinary least square regression analysis it is. So I'm just feeding our X data and Y data, and I would like to see that, model summary and how we seen that, last simple linear regression. Same way we can able to get it out it actually. Okay. For this one, you must have the stats model. You need to be import. Let's import now. Okay. If you want to be like, you need to import the pandas as well. Now, if you run this one, yeah. Nothing too much actually. So once if you learn one basic thing, then you can easily understand actually. So previously our R square value, when we have only single variable, when I'm considering only single variable, our R square value it's 0.43, right? But if I added one more variable, so that is a spending score, and by the time our R square value, it was increased to 0. Of 0.558. So here R square was increased. That means the variance, okay, the variance of income based upon the age and spending score has been increased. Let's see, adjust R square was increased or not for the previous thing on now. The previous one, the R square is 0.365. Okay. Yes, our adjust R square has been increased, right? See, 0.432, right? So that means, so spending score, spending score is also affecting. Okay, so our income is purely depending on the age as well as spending score also. Okay, so your statistic value and probability statistic value, it is greater than 0.05, and mm, 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 mm. So p value, see here, if we consider the p values over here, these are the p values are more than the 0.05, right? Okay, if it is more than the 0.05, what is the hypothesis testing? If p value is greater than 0.05, what is mean that? Is it statistically significant or not? This particular variable, age variable, is it statistically significant or not? That is my question. Hmm? Yesterday I told you, right? Okay. You can try it actually. So here we can see that skew and Quatermass values and Durbin Watson value and Jarko-Berra. So these are the different uh, statistical terms are there. So what is meaning of it and why we could use it? You can try to explore yourself at least. Okay. Yep. Now I would like to talk about the chi-square test independence. So what is the use of the chi-square test? Chi-square test of independence. Okay. So it could help you for test the two categorical variables. Test if two categorical means what? Qualitative data. Okay. Two categorical variables are related or not. Okay, that we can able to test with help of chi-square test. So far we seen only compare or only we can find the relationship between the only numerical values, right? Okay, but chi-square test it could help you for find the relation or how both categorical variables are correlated. Okay, for example, and let's take an example of gender and purchase and how the gender no is gender is independent of the purchase or not, that we can able to check with help of the chi-square test. So whenever we have two categorical variables are there and both how they are related and correlated, and that we can easily find with help of the chi-square test. Okay, let's see chi-square test example, and let's define the data first. I would like to go with defining the data. Okay, first I would like to go with defining the data. Okay, this is my data, gender and purchase. So male, female, female, male, something like that. Okay. So here the male was purchased or not, female purchased or not. So the corresponding data I do have it. Okay. So now I'm just for we need to, before we do that, we have to go for creating the some kind of contingency table. Okay. So we are going to be creating the contingency table over here. After that one, we need to go with applying the chi-square to contingency. So we have to provide this particular table over here, and then it will be give you the p-values and all. So you know that p-value indicating that, and p-value is a 1 and chi-square and we are getting very bad value because I'm just showing you how we can do it actually. And but so it is not a correct data, but if you have correct data, it will get the real values and all. Okay. So that's how we can simply with help of this particular function we can able to go with find the how you can easily compare the categorical variables. Okay, clear? Last but not least, which is ANOVA test. So coming to the ANOVA test, and you already know that if you want to compare the means of three or more groups to test if the means of three or more group same or not, okay, or different or not, okay, same or different, whatever it is, groups are different or same, that we can easily check with the help of ANOVA test. Okay. So here we do have a data for that, and the data is um we can take it anything. Okay. Okay, this is the data, right? So income and education level, and this is one specific person's and income as well as his education level. Okay, now I want to group, actually I want to group, apply the list of it. So here how many groups are there in education level? Only graduate is one, and postgraduate and PhD different groups, right? So we are taking that group by education level and corresponding income, and we are applying. Actually, these are the group we have it. There are three groups are there. Graduate is one group, and postgraduate is one group, and PhDs and one group, right? Okay, three groups are there. So the incomes of graduate, the incomes of postgraduate, the incomes of PhD graduates is same salary they are getting or different? Let's see now. Okay, yeah. So you know that p-value. If the p-value is more than the 0.05, then what is mean that? So your stat. Tell me, guys. Again, you are not following my points actually. If the p-value is less than the 0.05, H0 or H1? Hello?
F0.
H0.
H0 means what? H0 we are rejecting, accepting.
Accepting.
Hmm? Confirm.
Reject the null hypothesis.
Rejecting the null hypothesis. If you are rejecting the null hypothesis, means accepting the alternate hypothesis, right? What I explained, please tell me.
If p greater than 0.05, then fail to reject the null hypothesis. So it is statistically significant.
Okay, so fail to reject the null hypothesis, right? That means we're accepting. Okay,
Yes. Uh,
accepting and accept. Hmm. I don't want to confuse you. That's the reason, if it is less than the 0.05, we are accepting the H1. And if it is greater than 0.05, we are accepting the H0. Okay. Actually, but whatever I explain you, that is exactly terms we should use it. Okay. So what is H0 for this particular scenario? What is H0? H0 indicating that no difference, no significant difference, no significant difference between groups, between groups. H1 indicating that there is a difference. Is that correct? There is a difference in groups. Difference in groups. Okay. See, that means from this particular study, what you understood actually, even if you did the graduation, even if you did the PhD, even if you did the undergraduate, the salary was same range. There is no significant difference. Let's try now. PhD candidates, we can try to increase the salary. Okay. So post take the same data, and I'm considering, but different values I'm providing. Whether this particular situation, what happen, we'll see. Okay. So PhD, fourth element is PhD, right? Okay, one, two, three, a fourth. Hmm? This guy is getting the 7 lakh 20,000 rupees. Okay, wherever one more PhD in tall last, right? Okay, it's a 5 lakhs something like that. And coming to the mm, undergraduate. Undergraduate is what is that element? One, two, three, four, five, right? Fifth element. Fifth element is not getting you know 48,000. Is getting only 4,800 rupees. Okay. Undergraduate is not getting 62,000. He's getting only 66,200 rupees. Okay. Now save it and you can run it. See what is the p-value now? Tell me. Yet the p-value is different. It's more than the 0.05. And see here it is e power of 0.5. E power of 0.5 means what? 0.0005103. This is the value we are getting as a p-value. It is less than the 0.05 or not? Yes. If it is less than the 0.05, we should accept the alternate hypothesis, right? If you're accepting the alternate hypothesis, what alternate hypothesis is saying? There is a difference in group. That means if you study, if you're a postgraduate, if you are the PhD scholar, or if you are the undergraduate, so depends upon that, your salary was variating. So I hope you understood the difference between previous one and this one. Okay. How
Anjan?
this? Yes.
Yeah, I have a question. Like when we are explaining p-value to someone, we would during the hypothesis test, we would never say like we would never use the word accept. We will only use
Yes, that's
reject
yeah,
hypothesis, or we
that's correct.
fail to reject hypothesis,
That
right?
is correct. That is correct. Because
Yeah.
you might be confusing. That's the reason I'm using accepting and that's word. But
Yeah.
we should always say that rejecting kind of word. Okay, we fail to reject. We fail to accept that kind of thing. Only we should use it. Okay, we always do the negative testing. Okay, see, first we do the negative thoughts, and then we can come with some kind of positive opinion. Okay, that's what we need to do in a statistics also. Okay, so we are saying that there is no there is a difference. There is a difference. That is a negative thought for us. Okay, okay, there is a difference. That is a different. There is a difference. That is our negative thought. Okay, so that negative thought we are failed to reject and we are failed to accept. That's what you have to say. Okay. Yep. It's up to you actually how you should use it. That is not a big deal, but eventually you can easily understood. But you try to understand, p-value. It's a very important thing. Based upon the p-value only, we can reject the h0 or we can accept the h0. Okay, clear?
Yes, clear.
Okay. So I just changed the data for the graduates and postgraduates. See now what I'm doing actually. So this time, undergraduate data, I cannot change anything. It could be same values. Okay. For example, 62,000 and this is 48,000 itself. Okay. Now we can run it. Your p-value was increased. Again, it was increased. Hmm? Is it increased or decreased?
P-value increased, no?
P-value decreased. Sorry. in, increase it's a decrease or 0.05 and
No,
0.06.
comparing
Which
to
one is the mm,
it is increased the previous one.
uh, previous one is smaller than the uh, present one, or present one is smaller than the previous one, right? Yes, present one is smaller than the previous one actually. Okay, because it's a points, right? Okay, yeah, anyway, that is not a big deal actually. So we always consider the 0.05 or else some alpha value which is provided by the domain expertise. Okay. So if it is less than that particular alpha level or greater than that particular alpha level, we have to either accept or we have to go with either reject. So that's what we need to remember it actually. Yep. Any other questions? So this this particular ANOVA test and this particular chi-square test and correlations, these are all statistical things. It could help you to select the best features to select the important features to build your machine learning models or deep learning models. That is the reason we should go with use this all kind of stuff. Okay. See guys, tomorrow I would like to come up with some real world problem. So, you can keep that particular project in your resume as well. Okay. I would like to come up with some kind of real time project, and I would like to apply the all statistical things and visualization concepts, and even whatever I explain. Okay, so that all things, I would like to do it as a project. And first I would like to implement the project as like a Jupyter notebook. And if for time consists, like we can try to convert that one into the project structure as well. Okay, so that you can understand how the companies will able to create the project and all. Okay, clear? So that's it for today's session, guys, and nothing too much to discuss. And tomorrow, make sure don't forget, don't please try to come the session in in time, and might be we can it might be sufficient time, or we might not. I can try to cover entire project by tomorrow's session itself. Okay, instead of two different sessions and all, I can take the one long session and I can complete one project, so that you can keep that particular project in your resume wherever it is included. Okay, clear, right?
Yeah, clear. Okay.
Thank you guys, bye.
Thanks, Anjum.